This is the year 13 setup for a required practical and electromagnetic induction. Okay, so we've got a few apparatus here. The first one we've got is the surge coil connected to our cathode oscilloscope to measure the induced EMF in this coil. So in order to get an induced EMF, we will be using an alternating voltage, right? So this little device here is nicely mounted on a protractor, which allows you then to change the angle. So we first start off by setting up an alternating voltage in here. So by connecting that to around 7 volts, what we're using for today. The fact that you turn this on, there's a current that goes through here. And if you use your Fleming's, your right-hand grip rule, if the current's going this way, then the field is along the axis. However, this is an alternating current, so it's changing direction. So what are we going to measure? We're going to measure the magnetic flux linkage. How does it change with respect to the angle? So for that, we will be using a surge coil. So if we mount our surge coil right in the middle here, it's cutting across the fields. This surge coil now will cut across the changing magnetic field inside, and it will induce an EMF from Michael Faraday's law, which I'm going to try and measure using a cathode ray oscilloscope. So I'm going to connect my surge coil. Just allow the signal. There you go. So what we're seeing here is this surge coil is not connected to a power supply. This surge coil is actually getting an induced EMF due to the fact that there's a change in magnetic field in this bigger black coil, right? And as we can see, as we change the angle now between the flux linkage, we find that the induced EMF is changing. However, we only want to measure the peak voltage. So for that, we could switch our time base off, and we will just get a signal like that where we can measure peak to peak. But there's more to it in terms of reducing the uncertainty. AQE has asked that as part of an exam question. So how could we reduce uncertainty here, or how can we make our results more accurate? So one of the first thing to do is to use your X shift button. So when you use your X shift button, you allow now to take that to the center line. The reason why we want to use the center line is because all the other divisions they go up by 1 centimeter. However, the center line, they go up 0.2 centimeters, right? So that's the first change that you've got to do. Number 2, and again, just to show you, as you change in the angle, the peak voltage is actually being affected. But how do we increase sensitivity? How could we reduce uncertainty here? Well, reduce uncertainty by measuring over a bigger range. For that, we will need our Y gain setting, which is volts per division. So if I actually go for a smaller sensitivity, which is 0.2 volts per division, as opposed to earlier, which was 0.5 volts per division, I'm now measuring over a larger interval. So as I can see here, so I'll be reading the top. So that's 1, 2, 2.8, and it's actually quite symmetrical. So that's the peak. However, again, another method is to measure peak to peak and divide by 2, because then the uncertainty will reduce. Okay, so then the students will go off and plot their graphs for the relationship of EMF with the angle that the magnetic flux is changing.